All right, so let's get right into it. So Polygon formulas. Um, let's recall the four formulas. So the sum of the interior. So we're adding up all the interior angles. So it's going to be n minus 2 times 180. All right, if I want the measure of each angle, right, each angle, it's going to be the exact same formula except divided by n. That's the only difference. So n minus 2 times 180 divided by n. And if I want the sum of the exterior angles, that's easy. It's always 360. No matter how many sides it has, it's always 360. Always. And then each angle, each exterior angle will be 360 divided by n. So these are the four concepts that we're going to deal with. Okay. 16-sided polygon. If you saw the lesson on how to do it, you would notice that if n equals 16, this is the exact same example that I had. So if I run 16 through all of the problems here for A, B, C, and D, we're going to get 16 minus 2 times 180 comes out to 2,520 degrees. And then if I want each interior angle, I divide this by 16. And it comes out to 157.5 degrees. And then C, 360 degrees. If I want each exterior angle, I take 360 and divide it by 16. Comes out to 22.5 degrees. Right? How'd I get those so fast? It's because those were the examples earlier. You can literally use the Inspire, and it's just plugging into the formulas. So look at number 20. Or number 2, which is a 20-sided polygon. So A will be 20 minus 2 times 180. So 18 times 180. 3,240 degrees. Now I want to know how much each interior angle is. So I got to take that number and divide it by 20, the number of sides, right? Because in this case, n is equal to 20. So divided by 20, I get 162 degrees. Sum of exterior angles, it's always 360, no matter what. And then if I want to know how much each exterior angle is, it's 360 divided by n, which is 20 in this case. So we're going to get n is equal to 18. A 18 degrees, right? Because you divide it by 20. 360 divided by 20 is 18. Okay. Moving right along. It's going to be very repetitive, right? Very repetitive. So here we have, again, let's recall what the formula says, n minus 2, right? That's the number of triangles that we can make in a polygon. And there's 180 degrees in a triangle. So the total interior angles will be if n is equal to 36. 36 minus 2 is 34 times 180. 6120 degrees. And if I want each individual interior angle, I divide that by 36. Right, so it'll be n minus 2 times 180 divided by n. which is 170 degrees. The sum of the exterior angles, it's always 360. Sum of the exterior is always 360. And if I want each individual exterior, 360 divided by 36, which is 10. Okay, a 50-sided polygon. Again, n minus 2, right? The number of triangles times 180. So 48 times 180 is 8640, 8,640 degrees. Each individual interior angle will be that number divided by the number of sides. So divided by 50. $172.8 degrees. Sum of the exterior, always 360. And each exterior will be 360 divided by 50. 7.2 degrees. Right, that last one, it's just 360 divided by n. Okay. Let's read the instructions. So, given the measure of each exterior angle, right? Each exterior angle, 360 divided by n. Right? That's what each exterior angle is. We need to determine the number of sides. So we're looking for n. So they give us 20. So 20 is equal to 360 divided by n. Again, the variable is in the bottom. So n is equal to 360 divided by 20. You can swap the variable and whatever number is out here. Right? That's the beauty of algebra. So n is equal to 18 in this case. N is equal to 18. So now, all of these are going to be that simple, right? It's going to be n is equal to 360 divided by whatever the given number is, because the given number is the exterior angle. So this is going to be 360 divided by 5. Feel free to work ahead. So n is equal to 72 sides. $360 divided by 15 is equal to 24 sides. $360 divided by 10 is just n equals 36. $360 divided by 80. N is equal to 4.5. And 360 divided by 24. N equals 15. All right, so when you have an exterior angle, it's by far the easiest, right next to the sum of the exterior angles, right, which is always 360. So n is equal to, the number of sides is equal to 360 divided by each interior angle. Or the exterior angle, each exterior angle is equal to 360 divided by the number of sides. Either way. Okay, 11 through 16. It's very similar. The only difference is now we're given each interior angle. So each interior angle, remember, is n minus 2 times 180 divided by n. Okay, now, there's nothing wrong with setting the given value equal to this expression and solving for n. Like, there's nothing wrong with that at all. It's very noble, very doable, and there's nothing wrong with it. However, right, if I were to set this equal to n minus 2 times 180 over n, what has to happen? Well, the eyesore is that it's a fraction. So you need to clear the fraction first. So algebraically, you're going to multiply both sides by n. The n's are going to cancel on the right. You have to distribute and get 180n minus 360, right? Because 2 times 180 is 360. So really you're going to get 156 times n is equal to 180n minus 360. And from algebra 1, this is a one variable problem. You can combine like terms by subtracting either 156n or 180n and then dividing. Nothing wrong with this. But however, there is a better way. There's a more efficient way. So we're given an interior angle, which means that I don't know how many sides it is, but it for sure has an angle that looks like this. That's 156 degrees. Okay. If we were to extend this side out rather, we now create an exterior angle. It's going to be 180 minus whatever number they give you. So in this case, 150. So 180 minus 156 is going to be 24. So the exterior angle is 24 degrees, right? Exterior angle. Symbol for angle. We know, given the last 6 problems, how to solve when we're given an exterior angle, an individual each exterior angle. You just take 360 and divide it by whatever that number is. So in this case, for number 11, if the interior angle is 156, the implication, it implies that the exterior angle is 24, right? Because together they would equal 180, a straight line. So this means that 360 divided by 24, the exterior angle, will give us n, which is basically number 10 of the last problem. So in this case, n is equal to 15. So what I'm saying is, when you're given an interior angle, an individual interior angle, it's best to convert to an exterior angle. The numbers are much easier. The math is manageable more, in my opinion. Okay, so let's try it again. Let's keep doing that. $160. So 180 minus 160 is going to give us 20. 20 degrees. That's an exterior angle. So 360 divided by 20. N is equal to 18. 180 minus 130 will give us 50 degrees. Again, that's an exterior angle. Like we've converted it to an exterior angle. So 360 divided by 50. Something seems weird about this one. Something seems off, right? How can we have 0.2 of a side? I'm gonna have to cut that one out. But look, we gotta trust the math, I guess, on that one. Okay, 162. So 180 minus 162. We get 18 degrees. So 360 divided by 18. N is equal, so 360 divided by 18. N is equal to 20. (180) minus 105, 75. So the exterior angle is 75. So 360 divided by 75. 4.8. Might have to check the key on these, on if they're supposed to be decimals like this. So 180 minus 157.5. So the exterior angle is 22.5. So 360 divided by 22.5. Gives us N is equal to 16. All right, so the idea is that when you get a decimal for a side, right? Because you can't have a non-whole side, right? Because a regular polygon means that all sides are going to be equal. So you can't have a part of a side. So what this means is that they are not possible. It's only when the sides work out to a clean whole integer are these possible. So when you get n equals a decimal, right, any kind of decimal, it's not possible. Right? You can't have a regular polygon that has this interior angle. Is what this is saying. Just like 105, can't be done. Cannot. Okay. Let's keep it moving. So the key here is going to be identifying how many total degrees, right? How many sides there are, and then how many total degrees does that side polygon have? 1, 2, 3, 4, 5. So there's 5 sides. So this needs to add up to 540 degrees. So 540. If I know 4, I can always figure out the fifth by subtracting 110, 110, 160, 85. X is equal 75 degrees. Okay. Four-sided shape adds up to 360 degrees. So x plus x plus x plus 60 is equal to 360. This one's kind of obvious, right? X needs to be the same. X is going to be 300. But let's just say you didn't see that. So this is going to be 3x plus 60 is equal to 360. I'm minus 60. 3x is equal to 300. Divide both sides by 3. X is equal to 100 degrees. So 100 degrees. Okay, number 19. 1, 2, 3, 4. Again, quadrilateral. 360 degrees. So 80 plus 90, right? Because this is how much the box is. Plus 150 plus x is equal to 360. So 360 minus 80 minus 90 minus 150. X is equal to 40. All right, if you can do basic addition and subtraction, then we're in good shape. Okay, here's a hexagon, a regular hexagon. So all 6 sides are congruent. All angles are congruent. So the formula for this is going to be n minus 2 times 180. This is going to give me the total. You add them all up. But I want an individual one. I'm going to take that number and divide it by n. So if I have a hexagon, 6 minus 2 times 180. So this is going to be 6 minus 2 is 4 times 180. 720. This is 720. Total, when you add them all up. But I want it each. So you have to divide it by the number of sides. You divide it by 6. So 720 divided by 6 is going to be 120. So x is equal, each of these are equal to 120 degrees. Okay, 1, 2, 3, 4, 5. Again, 5 sides, pentagon will be add up to 540. So 540 is going to equal all of these. X plus 20 plus x plus 40 plus x plus x plus 80 plus x plus 60. So add up all the x's, add up all the non-x's. We got 1, 2, 3, 4, 5, 5x. And then, so 80 and 20 is 100. 60 and 40 is 100. So plus 200. This needs to equal 540. Minus 200. So 5x is equal to 340. So x is equal to 68. Right. So if you plug in x, right, this would be 68, 88. This would be 108, 128, 6 plus 8, 148. And then all these should add up to 540. Okay, 22 is more of the same. I'll let you practice that one. 1, 2, 3, 4, 5, 6. It's a six-sided shape. Another quadrilateral. Adds up to 360. Here we have 1, 2, 3, 4, 5, a pentagon. Here, you use the fact that this is a straight angle. So 180 minus 68 will give you this interior. And then 180 minus 70 will give you this interior. And then these two must be the same. So 2b (25) is more the same. All right, 26 is interesting. So to figure out 26, a couple of ideas. Some geometrical facts, right? Vertical angles are congruent. So angles that are across from each other. And a triangle must equal 180. So 180 minus 78 minus 30 will give us 72. And because it's 72, a straight angle is 180 degrees. So C has to be 108, right? C is equal to 108. Again, vertical angles are congruent. We have 180 minus 78. (102). We have a quadrilateral. So four-sided shape. So it must add up to 360. So to figure out what D is, we have to add up 108, 102, 44. So 254. And then subtract it from 360. So 360 minus 254. D is 106. Now, were there other ways of finding this? Yeah, probably. This is just my reasoning, what I saw. Okay, 27 looks fun. So solving for F. 1, 2, 3, 4, 5 sides, so 540. This needs to equal 540. So 117 plus 108 plus 3F, because they're all F are congruent. So 540 minus 117 minus 108, 315 is equal to 3F. Divide both sides by 3, and then F is equal to 105. 105. Okay, so I think next would be best to find this angle. So there's 360 degrees in a circle. So 360 minus 108 minus 130. We see that this is 122, which is nice because in a 1, 2, 3, 4 quadrilateral, this needs to be 360. So we have 90. That's what the box represents. 122 and 66. So 90 plus 122 plus 66, 278. So 360 minus 278 is going to be 82. E is equal to 82. I know it went fast, but it's the beauty of the pause button. Okay. K is fun, right? K is fun because we have these arrows represent that they're parallel. So here's two parallel lines cut by a transversal. And we know that alternate interior angles are congruent. So K is equal to 38 degrees, right? No math involved, just logic. Hopefully that's correct. In a hexagon, 1, 2, 3, 4, 5, 6. I feel like we found this answer already. In a hexagon, oh, we have this nice little chart. I guess I should have led with this. So here is a chart with some useful information. So you can pause, write this down. So a hexagon has 120 is the measure of each interior angle. So M is 120. I guess we could use the formula, but you know, chart's nice. All right, 29. Let's go. So exterior angles must add up to 360. Must add up to 360. So if we add up all of the interiors, or all of the exteriors, so these are all B, so 3B plus 69 plus 43, and then plus, not 68, but the exterior, so 180 minus 68, 112. So we add them all up. So 360, or we're combining like terms rather, 360 minus 69 minus 43 minus 112 is 136. Is equal to 3B. Divide both sides by 3. Here we get B is equal to 45.3 repeating. Okay, so they're all regular polygons. Okay, so there's 360 degrees in a circle, right? In the circle, there's 360. So we need 360 minus these symbols right here. So minus 90, minus 90, minus 60. So C is equal to 120. Not only that, but it's a regular polygon and it's a hexagon. And we just found out in the last one that in a hexagon, the interior angle is 120. So however you want to rationalize that. Okay, so what do we have here? 1, 2, 3, 4, 5, 6, 7. Heptagon. A heptagon, aka septagon. So a 7-sided polygon. Each individual interior angle 128.571. 128.571. .571. Okay, and E, since these are congruent, it's going to be 360 minus 128.571. So this is going to be 231.429. I want, that's this whole part. So I need to divide it by 2. And I get that E is equal to 115.7145. Okay. 32. It's all about what do you see first. Like what you see is different from what I see, right? And vice versa. So the first thing I see is that there is a big triangle. And I know that there's 180 degrees in a triangle. So to figure out F, we do 180 minus 56 minus 94. So 180 minus 56 minus 94. F is 30. Okay. The next thing I see is that we have two parallel lines. Right, that's what the arrows represent. And it's cut by a transversal. And I know that alternate interior angles are congruent. So immediately, K is equal to 30 as well, right? Degrees. And if that's the case, then that means I can find G no problem, because there's 180 degrees in a triangle. And there is definitely a triangle right here. So this is going to be 180 minus 44 minus 30. 180 minus 44 minus 30. 106. Now, could you have found this some other way? Absolutely. Again, this is just the way that I recognized it. If G is 106, right, because now we need to find H, we're not done. I can do 180 minus 106 to make 74. This is 74, this angle. And that's nice because here we have a quadrilateral. So to figure out H, we can just do 360 minus these three values. 360 minus 74 minus 56 minus 94. H is 136. Okay. Number 33. Find N. What the heck is N? N is the sides of this regular n-gon. So this n-gon has an unknown amount of sides, but the only clue that we're given is that this regular n-gon, regular 10-gon decagon, and an equilateral triangle press up against one of the sides. So I know that this is going to be 60, right? This is going to be 60 degrees. And a 10-sided polygon, right? A decagon, we see that each individual side is 144 degrees. 144. So this is going to be 144. So that means that's going to imply that this side, right, because there's 360 degrees in a triangle, 360 degrees in a circle, 360 minus 144 minus 60 is 156. 156. So what that means is that an individual interior angle of a regular polygon, n is equal, n is not equal, n is going to be minus 2 times 180 divided by n is equal to 156. Okay, so here, since we have an individual angle, if we extend this angle out, right, if I know that each of these are 156, 156, 156, right, each of these are 156, then the exterior angle that is created is going to be 180 minus 156, which is going to be 24. The exterior angle is 24. Right, this is an exterior angle. Now, I mean, we probably could have been done with this problem already, but you know, like why? So an exterior angle is 24 degrees. So if I do 360, right, divided by 24, I'm going to figure out the number of sides. 360 divided by 24 is 15. So this is actually a 15-sided polygon. Okay, 34. We're almost done. Same idea, right? A square is going to have 90, and a regular pentagon, I know that a pentagon has 540 divided by 5 sides, is going to be 108. So this is 90, this is 108. So that means this side, so 360 minus 90 minus 108 is 162. So each of these are 162. Each of these are 162. If I extend the side out, this side's going to create an exterior angle. So 180 minus 162, I'm going to get 18. The exterior angle is 18 degrees. And why is that nice? Because the number of sides is equal to 360 divided by the exterior angle. So that means 360 divided by 18 will give us n is equal to 20. So this is a 20-sided polygon. All right, the last problem. It's always a doozy. Okay, you've designed a flower garden as shown by quadrilateral ABCD. So if we name, the naming convention is the vertices. So A, B, C, D. The measure A, so A, is twice the measure of D, so 2 times D. And D is 2 times C. The measure of B is 115. Okay, so this is 115. Find measures A, B. Okay, so let's just call one of these X. Doesn't matter which one. But, okay, it does matter which one, but it doesn't matter which one, right? Because I'm going to make the smaller one equal to X. And now this is going to make the math better, because if I make the larger one X, I'm going to have to run into fractions. So if C is equal to X, it says that D is 2 times X. So D is going to be 2 times X. And then A is 2 times that number. So 2 times 2 times X, which is basically 4X. So now this is a quadrilateral. So 360 degrees is equal to the sum of all these added up. X plus 2X plus 4X plus 115. 115. So 4, 5, 6, 7. This is 7X plus 115 equals 360. So 360 minus 115, we get 245. 7X. Divide both sides by 7. X is equal to 35 degrees in a sense. So C is equal to 35. D is equal to 70 because 2 times 35 degrees. And A is going to be 4 times 35. So 2 times 70 basically, which is 140. And just to confirm, 140 plus 115 plus 70 plus 35 is 360. So we good. Okay, hopefully this helps. If you have any questions, leave it in the comments and I'll try my best to answer them. Be sure to like this video and subscribe if you haven't done so already. Peace.